Welcome to today's webinar. This is our continuing series, What's New in aPriori. This particular webinar will be featuring all the amazing new capabilities that are going to be delivered in aPriori 2020 R1. Congratulations to our product management and product development teams who've done an awesome job bringing out a new product with tons of capabilities. We've got a lot to talk about today, so we're going to click right into our content as quick as possible. But before we begin, I'd like to introduce you to our speakers today. We've got Dr. Karsten Hochmuth, who is a senior member of our product management team, along with Karen Gold, also another longtime member of our product management team. So we'll start off with Karsten talking about aPriori Cloud and all the new capabilities delivered through that platform. We will then get into key application features, made some really great strides in introducing some new cost models, enhancing existing cost models. We'll also talk about some of the progress we've made in accelerating time to value, getting your systems up and running as quickly as possible. What are our release plans? And then, as I mentioned, we'll try and take a couple questions at the end. So with that, let's turn it over to Karsten and get into the good content that we prepared for you. It's all yours, Karsten.
Great. Thank you, Rick. And welcome to today's What's New webinar on 2020 R1. As Rick mentioned, we have lots of exciting content to share and happy to be here today and talk through all the great new stuff that we've introduced. So the first topic that we want to cover is the aPriori Cloud solution. And really, we've been seeing some strong and really accelerating growth in both existing and new customers choosing cloud, either migrating to cloud or setting up brand new deployments or SaaS as their deployment model. We're up to, I think, over 15 production accounts and growing fast and likely to more than double that in the upcoming months. So since the initial launch of our cloud solution, I wanted to start with sort of a general picture of what the cloud solution is and how it's grown, especially in the last release. We've really continuing to add new products and features to drive more use cases, to drive more value and ease of use in the cloud. So this picture, if you've been in past webinars, is what really our initial cloud launch solution represented, with core capabilities where we provide access to 3 main applications, all through a web browser. So you don't have to install anything. aPriori manages all of this for you in the cloud. So you have access to AP Professional, the application you all know well, through a streaming service. You have access to Cost Insight Design, which was a new application that we built specifically for design engineers. So that's seen a lot of growth, and I have some nice features to highlight there. And of course, we have a reporting tool, analytics solution that is out of the box available also in the cloud to sort of give you value tracking, analytics, and all kinds of great ways of building ad hoc views and reports in the cloud. And that's supported by a series of services. So the real picture that's sort of underneath all of this on our infrastructure on AWS is much more complex. But at a high level, you have this layer of services that scales to respond to the demand and use of the application. And then, of course, there's a database of databases in the back end that's managing all of that information. So that sort of, think of it as that's the baseline where we started, I know at this point, almost 2 years ago with our first production account, and are now building that out and with a lot of great new features. So a couple of things to highlight today is, one is we'll be introducing this new Cloud Home portal. So to date, customers have had sort of separate logins to each of our cloud apps. This, I think, is a great new tool, and I'll talk more about it in detailed slides about how to connect and have sort of a single homepage place where you go to get at everything that is aPriori Cloud. With that come a set of, this will broadly call it identity services, sort of a general industry term, but what it represents is sort of some back-end services that allow us to manage users, manage licensing, manage all the different cloud accounts you have access to, and also is enabling us in this release to keep expanding on the ways you can connect to the cloud. So you have the sort of user password, of course, you have the ability to add multi-factor authentication for additional security for users. And with 20.1, we're introducing the ability to do a federated SSO or SAML-based connection with your own identity provider to the cloud. And we already have a number of customers that are going to be working with us to roll that out in the next release. And then really the biggest component, I think, what we introduced relatively sort of earlier this year, and it was a great big new product launch, Cost Insight Generate, and that has several components. It allows sort of a notion of automated costing workflows, and introduces the ability to do several key things: is to connect to your PLM system. It runs automated costing analysis through managing sort of the workflow and notification on that, and has a new sort of administrative UI for that as well, called Cost Insight Connect, where you configure these connections and configure these workflows and how you consume data out of, let's say, a PLM system and make it available to designers and other stakeholders in the organization. So in the following slides, I'll highlight several of these key features, some enhancements to existing products, and talk about these new ones. So first off, the most important one, really, Cost Insight Generate. I'd like to sort of talk about sort of what the scope of what it can do. So imagine if you could automatically analyze parts for cost and manufacturability when they're checked into PLM or based on some defined triggers in that source system. You can identify the parts that have the most DCC and DFM manufacturability issues. You can highlight the most important cost drivers of these parts and provide guidance for remediation. And you can get the right information to the right people at the right time. So in Cost Insight Generate, what does this look like? There's a number of different workflows that are enabled. I think one of the most interesting ones to highlight and high value ones is for the design engineer. Often a design engineer is very busy designing, so they any kind of tool that helps sort of automate their workflows and gives them feedback very directly and without too much extra effort is fantastic. So the designer would typically check designs into PLM on their system, and then with Cost Insight Generate and the ability to connect to the PLM system, we automatically cost all those checked in components in aPriori. And from that data, we can then provide relevant cost feedback and design, manufacturability, DTC feedback, even reports attached back into the PLM system. But maybe more importantly, at the same time, we can also do, then it triggers email notification with reports on outliers, reports on what we call a manufacturability score or rating, and provide that back to the designer. So the designer will get an email, they'll have a list of, here's the 5 parts that you checked in the last day or last week, or 10 or 20. Here's things you need to review. Here's parts that might have some real manufacturability issues or might be expensive. So that gives you then a great segue to explore that further within, in this case, you're jumping into Cost Insight Design, our design application, to review and evaluate and work on it further. And then, of course, the data is all managed in aPriori, so it's available to other stakeholders and professional in our reporting tools. So it's just one example of one of the critical workflows that CI Generate enables and is newly available with the cloud releases this year. So lots of great stuff there. And I'd like to, at the end, we'll highlight, there's a link here that should work in the PDF. There's also a link at the end of the deck that gives you a connection to a webinar that was run earlier this year on Cost Insight Generate specifically. A couple of new things to highlight. We're continuing to build out PLM integrations. The Siemens Teamcenter one is new with this release, building on top of the one we built initially for Windchill. Also, another element here that's new is what we're calling a file system agent that allows you to sort of run these same kind of workflows, but just looking at a folder of files as the feed or as the input. So if you're not directly connected to PLM, that's a great way to also pull data in and cost data in these workflows. So those are sort of new features on the connection side. And also another element worth highlighting, this this came with release earlier in the year, but I think this is available in CI Design and CI Generate. We've built on top of our DTC guidance across many different process groups and introduced the notion of a risk rating. So it's sort of a summary assessment of where your particular design or part is at based on the number of issues that we see. So it's a great quick indicator of things that you should investigate and look at, and allows you to dig in and say, well, let me look at these high-risk parts first, address those issues, or maybe address ways of reducing their cost and go from there. So really closes that loop automatically back to the design engineer and gives them great feedback. So those are highlights on Cost Insight Generate, and I am going through this relatively quickly. We have a lot of ground to cover, so certainly if you have questions or want to dig into in more detail, reach out to your team, reach out to contacts at the end, or explore some of the other webinars that we have. I'd like to highlight a few other great new features. This is in Cost Insight Design. So we've recognized that design engineers are also often interested in guidance. We highlight an issue, for example, like a sharp corner in manufacturing and machining. Well, why is that a problem? So we provide sort of built-in guidance that allows you to quickly pop up a descriptive images and visuals, and this is something we can keep building on and evolving as we add more guidance. So this is an example here of if you wanted to learn more about why internal sharp corners are bad in machining, it explains that to you and how you might mitigate that in your design. And we have that kind of guidance for every one of our processes and every one of the design sort of issues or feedback that we highlight. The other, I think, nice new feature that's sort of connected to this is we're introducing guided tutorials. This allows a user to do walkthroughs and very quickly learn about how to cost, let's say, your first part, how to build your first comparison, how to understand the selections and inputs. This, again, is something that we expect to grow and configure over time and get feedback from our customers. I think we previewed this at our last conference last year with, I think, some great positive feedback. So this will be available for everyone to use within the 20.1 release. A few other key highlights of new features. We added two-model costing. Two-model machining has been around for certainly many years in AP Professional. There were some specifics around how you have to manage the connected parts and the relationship. So we just introduced this in CI Design as well. So it's nice to have that now there as well, and you can identify the source model and the target model, even have multiple levels of two-model machining for, let's say, raw casting, rough machining, and finish machining if you wanted to. So that's a new feature, a new process group support in CI Design. The other great new feature, and this is, I'm highlighting this in the cloud section, but it actually applies to the full product suite, to AP Professional and Cloud. There is a great new capability, and I know a lot of you have been asking for this for a long time, the ability to change unit systems to go beyond just the basic English and metric or system and metric that we've had for a long time. So now you have a number of out-of-the-box systems. You can define custom ones. You can individually control length, mass, time units. And we've also brought the decimal place control into the UI, wherein that was really driven more by a properties file. So now you can control it in your user interface. You can set it both in CI Design and in the desktop. And it's a user preference, so that preference carries between the applications. So whether you're opening it, whether you're setting this in CI Design or aPro, as you're using both applications, maybe in your workflow, those preferences carry between those two. So great new capability, and looking forward to hear feedback as you explore those new features. See a couple more on the CI Design side. We are also been actively working on the enhancements to plugins. So a couple of things to report there. So in the cloud, we build plugins to work with CI Design to support the designer workflow to go from the CAD system to CI Design, and extended that to a total of 5 different systems. So Creo, CATIA, SolidWorks, Inventor, NX. I think Inventor for the cloud is new, and there's also some new formats that Karen will speak to in a later slide. And ease of use, so we're also introducing some new ease of use enhancements by using a Chrome embedded browser instead of the older IE11 browser for all the cloud ones. So great new ways for connecting from your CAD system to the cloud solution. See a few more items before I pass it over to Karen. For our deployments, we provide a global deployment infrastructure, working with Amazon as our infrastructure provider and their main regions or big data centers all over the world. We recognize that we have global customers that have users in geographies really everywhere. Many different countries in Europe and China and India and Japan and in the US, and sort of even extending to Central and South America as well. So we currently have 4 main data centers that we work with, the US East region, Dublin, Singapore, and Tokyo. And we are certainly looking at expanding to others that Amazon supports, and making sure that users from all over the world have the right connectivity into our cloud solution. So I think this is the last slide on cloud, and it gives you a bit more detail on the new cloud homepage. I think it will be a great new handy feature for you. One, I think, big ease of use enhancement. You only have to remember one URL, cloud.apriori.net, and that's it. So that you bookmark that and you log in, and then based on each user's access control or permissions, you actually only see the applications that you're authorized to. So depending on your role in the company and depending on which apps you use the most, I think that really helps. We have as you can see, there's a resource link that connects directly to our support center, and we have a new mechanism to push notifications into this portal. So if there's maybe a planned downtime, if there's some license sort of expiration coming up or renewal that we want to push, or other message about key events coming up, we can sort of bring that into this surface, and then all users will have access to see that. We've streamlined the workflows for login. If you have used the cloud, we eliminated this sort of second login step, which I think will make that a lot easier. And interesting, I think, to a number of our cloud customers is the support for federated SSO using the SAML standard that allows you to connect, basically authenticate in your own internal IDP, identity provider. That might be something like Okta or Azure or ADFS. There's a number of different vendors in that space. So we strive to support as many of those as possible that support the SAML standard. And then once that's configured, you actually have effectively a passwordless connection into the cloud solution based on your corporate identity. So great new ease of use, I think, around connecting into the application, and you'll see more features here, I think, being built out over the next major release cycles over the next year. So I think with that, there's a few sort of small notes on service pack comments at the end that I'll cover. But with that, I'd like to hand it over to Karen.
Thank you, Karsten. Very exciting to see all the expanded capabilities in the cloud. And now I'm going to talk about some of the new end user capabilities that are in our aPriori professional desktop solution, and then move into new cost models and cost model enhancements that are available in both our desktop and cloud solutions. I'm very excited to talk about our new matrix costing capability. This is a capability that some of our users have been requesting over time to support sourcing and quoting use cases. And what it does is it allows you to easily create, cost, and compare a range of production scenarios for a given part or assembly or a set of components in a roll-up. If you can see on my right-hand dialog screen here, it allows me to specify multiple possible values for my production region, or VPE. In this case, I've chosen 3: Eastern Europe, Mexico, and USA. Multiple possible values for annual volume, and I've got 3 volume points at 1,000, 10,000, 100,000 parts per year. And then also multiple possible values for batch size, or in this case, a batch frequency, 12 or 24 batches per year, so once or twice a month. Before, in order to create and evaluate all those different scenarios, a user would have to sort of manually create them, being sure to specify all the inputs correctly, and then cost them, put them into some kind of roll-up or comparison, and evaluate them. aPriori automatically does all that for you. And if you think about it, there are 18 different scenario possible combinations here: 3 VPEs, 3 annual volumes, and 2 batch sizes. So this really saves a lot of time in generating these scenarios, and also makes it much less error prone. So we're really happy to be able to offer this capability now. I noticed it's been requested over the years, but recently was also escalated to be a priority 1 enhancement request by a couple customers, so we're happy to turn that around quickly. And then for those customers who are costing weldments in aPriori, I wanted to make you aware of some work that we did to make that easier for you. In fact, one of our own application engineers recently brought to my attention that he had been working with a customer and was really having trouble defining all the welds he wanted to on a large assembly. It often took him several tries to select the desired edge on which to define the weld. Sometimes he'd click on the weld, but it wouldn't get selected, or sometimes a different edge got selected. And he had to do a lot of zooming and rotating of the CAD model to achieve this. He just wasn't being efficient. So that concerned me, and I had our dev team look at it very quickly, and we actually fixed 3 distinct technical issues that were all contributing to making it hard to select edges in some circumstances. I won't get into the gory details, but the upshot is it's now much easier and faster to select an edge to apply a weld, and it should only take 1 try. In fact, the application engineer called me up a week ago after he first installed our new release, just to tell me how much better it was and how much he appreciated it. So that's always nice to hear. And now I'm going to move on to some of our new and enhanced cost models. So we are very happy to announce we now have a baseline cost model for investment casting. Investment casting is a really cool process that's used across most major industry sectors, and it offers advantages over other casting and metal forming processes, including lower tooling costs, the ability to achieve tighter tolerances and surface finishes, and higher material utilizations. So this process is another one that's been a popular request among our customers. We had over 30 distinct RFEs logged into our database. So I do want to thank the customers who provided us parts and information to support our development of this cost model. For data security reasons, I can't show you pictures of the exact parts they shared, but I included some pictures of similar parts. Up on the top, you kind of see this brass colored part. It's a valve color, but it is similar to a part we received from a customer. Below it, it's a wax pattern of a jet engine turbine blade. Also very similar to some parts we received from customers. To the upper right is a 5th wheel coupling for tractors and trailers and tow trucks. These are sometimes made by investment casting, sometimes by forging. And then finally on the lower right, we've got an air valve body, so another application of investment casting to high performance aerospace applications. Now, conceptually, investment casting isn't too difficult of a process. It involves first making a wax model or pattern of the desired finished part by injection molding, and then assembling those wax patterns into a connected tree as shown in the lower left here. Then that whole tree of wax patterns is dipped into a ceramic and sand slurry to make a shell, which when it's hardened, the wax can be melted and drained from the shell, and then that empty shell serves as the mold for the molten metal. And once the metal is poured and cooled, you can just remove the parts by breaking the mold or shaking it out. So conceptually, it's not a difficult thing to understand, but in practice, there are many detailed process steps involved in manufacturing a part by investment casting, and we strove to make our cost model very complete and automated and mechanistic. So as you'll see on the right here, my screen shows all the steps included in our routing and investment casting. If I counted correctly, there are 18 required process steps, as well as several optional ones. And the cost model also supports many variations of how investment castings are made. There are different choices of tree types or layouts. Like I said, we have additional or optional processes that may or may not be included. And we try to be automated, for example, dynamically determining the number of parts in a tree that has a kind of a strong impact on the number of parts produced simultaneously, so it does impact part cost. And I do want to mention that this new investment casting cost model is available in a new process group, which is separately licensed. And then also in casting, we have some new and enhanced cost models for castings and forgings. We have a new cost model for parts made by machining ring-rolled forgings. The ring-rolling forging process is used to make seamless rolled rings that have very high strength and good fatigue and impact resistance. And it's really used for a wide range of part sizes. The diameters can range from just a few inches to over 300 inches, as you see in the middle picture. And then these rings are then machined to make part types like turbine engine components or other components in industrial equipment. So to cost such components, you would use the new ring-rolled forging process routing together with the two model machining process group. This approach does require you have two CAD models, one that represents the raw ring shaped forging. You cost that in our forging process group in this new routing, and then one representing the finished machine part that you cost in the two model machining process group, specifying the forging scenario as the source scenario. I'm also going to mention that this routing, which is in our forging process group, includes several other processes, sawing the stock, preheating it. We have an open die press that's used to sort of upset the malt and make a toroidal preform that's then put into the ring rolling press. The preheat process in that routing is also already used in our existing closed die forging cost model, and we updated that preheat process also to make it more mechanistic. So that work will also benefit anybody using the existing closed die forging routing as well. Next, I want to move on to sort of a geometry extraction enhancement that benefits cast and injection molded components. And what it is it's a really better recognition of how we characterize undercut volume, so features that are undercut with respect to the mold opening direction. And that goes to giving us better tooling type and number of side actions, the type of side action, and a more accurate tooling cost estimate. So historically, what you'll see on the top here is a part that has an undercut due to sort of the neck down region, right underneath sort of the top rim of the part. And historically, aPriori sometimes extracted this undercut volume into a single, we call them void GCDs, that was actually too big. you couldn't actually, you'll see historically in the before picture, we extracted a single void that encircled the entire neck of the part, a kind of a ring-shaped void. But you couldn't actually make that undercut with a single side action. Now what we do is we do a better job of determining when we can split these voids into two voids that represent two undercuts that can be made by two distinct side actions. So in the lower pictures now, you'll see we now have two voids, one that can be pulled to the left and one that can be pulled to the right without interfering with the part. So this will kind of automatically give you better tooling characterization and cost estimates. And then finally, I wanted to talk about an enhancement to our sand casting routing. We've updated it to better account for when we incur additional handling time and costs. Many sand casting processes in aPriori include a handling time component to move the part from station to station with each process. So that handling time and cost can be quite significant for larger parts. For parts over 2,000 kilograms, for example, it can be 30 minutes each time the part's moved. But depending on the actual configuration of the line, in reality, one or more of the processes in the routing may be performed at the same station rather than being moved to a distinct station for each process. So for example, you might do finishing and visual inspection at the same station. So we've added a new process setup option. It's called disable handling time to each of the routings, each of the processes in the routing that involve a handling time component. And you can just use that by checking it on or off to indicate if that process is performed at a distinct station or at the same station as another process, so we don't double count the handling time. And as always in aPriori 2020 R1, we've made a number of enhancements to our machining cost model. And the most impactful thing that we've done is a full-scale review and updating of the cutting data that we use to calculate the cycle time and cost estimates for milling and drilling operations. Our goal was to ensure that we're providing a robust, defensible set of cutting data across the spectrum, by which I mean directionally correct behavior for different material types, for different operations types, both roughing and finishing, and different tool sizes and types, both solid and insert tools. So we did a lot of research and we validated our updated cutting setting data with multiple sources, including multiple subject matter experts, published tooling vendor data from a variety of machine tooling vendors, and even correlated it with customer feedback that's been provided to us over the years. In addition to updating the cutting parameters, which are things like feeds and speeds, number of teeth, engagement factors, and so on, we also reviewed the cut code classification for all of our materials, and we made some corrections. In some instances, some materials that did not machine similarly were nonetheless grouped incorrectly into the same cut code. For example, Hastelloy X and Haynes alloy were in the same cut code. Now we've separated them so that their machining data will correspond. And then finally, we've also updated how the cost model reacts to material hardness values. The hardness in the material will now more appropriately influence cutting settings. So the impact of these updated settings is significant, as you can see from the table on the right, but we do feel confident in our data updates. This table summarizes results from many test parts. It's a test set of, I think, 30 test parts, kind of representing a good spectrum of our customer part types. And what we did is we took those and we cost that set of parts in each of these 5 different material families. And what we're presenting is average results, but on average, because of the cutting data changes, almost all materials will machine faster than they did in the previous release of aPriori. So that means the material removal rates are higher, therefore the cycle times will be lower. The exception is carbon steel, which had a slight decrease in material removal rates and therefore a slight increase in cycle time. And some of these materials changed somewhat significantly. Aluminum in particular is notable. The part cost is not as impacted as chip cutting time because things like setup times did not change. And some other machining enhancements in this release, We now, in the stock machining process group, we support estimating the cost of a part machined from Hex Bar stock. We've also had this request recently from several customers, one who escalated it to a priority 1 enhancement request. So again, another one that we're pleased to have turned around pretty quickly. I will note that while the bar and tube fabrication process group already provided some support for estimating parts made by Hex Bar stock, the stock machining process group is recommended for some part types and those with more volumetric material removal. And in particular, the stock machining process group is also better suited for parts where material is removed from all surfaces of the hex, so the raw stock is larger than the finished part dimensions. In this release, we also improved tool size and cycle time estimates for rough milling and contour finish milling operations in some circumstances. In particular, we addressed issues in which we selected overly small tools to rough a volume or contour an entire surface, resulting in inflated cycle times. So in the case of roughing, our tool size still is computed and constrained by the geometry on the part, in particular sort of corner fillets that limit how large a tool can fit into the corner. But however, we now allow for some margin of material to remain on the wall after the roughing passes to be removed by subsequent finish machining passes. And so as such, we can choose slightly larger tools than previously. And especially when you get down to smaller tool diameters, a somewhat larger diameter has a pretty big impact on reducing cycle time. And we did something similar in the case of contour finish milling, as shown in this picture of a purple part. This is sort of a pocket, but the bottom of that pocket is not a plane. It's kind of a curved, lofted surface. You see these on aerospace parts quite commonly. And sometimes we chose a very small diameter ball end mill if the surface was bordered by a small fillet, like the one shown in the picture here. We use that small ball end mill to contour the entire surface. But now, in general, we will pick 2 tools, a larger tool that can finish the interior of the surface and a smaller tool just for the edges, the portion of the surface near the edges where there is a small fillet present. Both of these had an impact on producing much more reasonable cycle time estimates. We made a whole host of improvements in our extrusions cost model. We introduced that first release of the extrusions cost model in our aPriori 2019 R2 release. And so there's a bunch of enhancements. Now, for one thing, we've improved our geometry recognition to better support the complex parts we've received from some of our early adopters. And in particular, we better recognize extrusion profiles for parts that are either very heavily machined and have very complex extrusion profile cross sections, and also are bent. Previously, for some of those part types, we would just fail to recognize the cross section entirely, and that would prevent you from costing the part. Now we recognize them much more frequently. And we also are better able to handle parts where there are bends that aren't modeled with very high fidelity. Often we got some parts that had very sharp, abrupt bends, like no tangent portion. We now can handle those as well, even though they're not modeled particularly realistically. And then finally, we are better, particularly faster, at analyzing heat sink parts with pins in both directions and a significant amount of material cut away as well. We've also updated the age heat treatment process. The age process is included in the extrusion routings by default. And what we noticed is that it was, in many parts, it seemed like it was contributing too high of a percentage of the fully burdened cost. And what we did is we looked at the cost model. It was one of our older cost models, and we made it more mechanistic. Previously, it was based on a simple sort of cost per mass heuristic that we had some empirical data support, but now it's based on a full mechanistic model, things like how big is the part, how many can fit in an aging oven, what are the, how long is it in the oven, what are the overhead rates of the oven, and so forth. And so that's overall had the result of lowering the aging cycle times and costs relative to the other processes in the routing. And anybody else who's using that age heat treatment process for other models will also benefit from those improvements. It's not only for extrusions. We've also added a new bending process. It's called the Profile CNC Bend, and it's kind of a hybrid or combination machine which has the capability to make both large radius bends and small radius bends using either a 3-roller bending mechanism or a rotary draw bending mechanism, and it can switch the part between those two mechanisms depending on the required bend radius. So the reason we did this is that it allows us to estimate parts that have both these large and small radius bends present on the same part. We received quite a lot of those types of parts from a particular early adopter customer and wanted to make sure we could successfully cost all bends on the part. And then finally, we've updated the model to better handle sort of very heavily machined extrusions that we also have seen from some of our early adopters. In truth, we were not necessarily setting out to support those part types when we initially designed our extrusions cost model, but that is the part types our early adopters are using. And so we've done a couple of things based on their practices. One is that we now provide an option to use 3 and 5-axis mills to perform the post-extrusion machining, in addition to the 3 and 5-axis routers that we had in our initial release. Routers are still the default, but you can make it mills your default in your deployment. And then we've also added some new material removal operations for machining to represent some of the cutout machining on the part that results in more accurate cycle time estimates for those types of material removal on the geometry concerned. Finally, one thing I wanted to mention is we've made it a lot faster. We've increased or decreased the time it takes to cost a part in the bar and tube process group, whether it is an actual extrusion, a custom extrusion part, or a commodity bar and tube stock form type of part. What we did is there are so many different combinations of processes and the various routings in this process group that when you evaluate all those possible alternative combinations, it was a lot of routings. It was up to 80 routings that could be evaluated for a single part, but some of them weren't really relevant and would then fail to cost because of our feasibility rules. A simple example of that is if the part was a solid bar, it would evaluate using a tube laser, but it would fail because the part didn't have a tube or hollow cross section. Now what we do is we sort of more intelligently prune the routings that are going to fail feasibility anyway, so they don't get evaluated, and that cuts down on a lot of costing time. It's up to 20 times faster for some parts. Moving on to our sheet metal process group, a number of enhancements there as well. The first is that we have a new routing in the process group, which uses a 2-axis router for cutting out blanks and holes in the part. The process has been requested by aerospace customers who prefer it to using lasers, for example, since it won't produce a heat-affected zone of the material. And this routing is intended for use with aluminum and copper parts, less than 1/4 inch thick. It won't be evaluated for steels. And then we've also updated our laser punch and plasma punch processes to provide more transparency into how individual GCDs or features on the part are made. We did this a while ago for our turret press process, and what we're really doing is the same kind of enhancement to these two processes, laser punch and plasma punch. Before, we sort of analyzed how each GCD would be made, but we only sort of totaled it, the numbers up at the process level. Now we provide much more visibility at each GCD as to what operation specifically was assigned, and it lets you have a lot more transparency and sort of align it with things like the hit count and cycle time that was summed up at the part level. Another thing we've done is improve our cutting rate logic and our machine selection logic for all the 2D cutting processes in the sheet metal process group. And the reason that we did this, we wanted to make sure that the machine that we were selecting ultimately is the one that would result in the lowest part cost. There's essentially a trade-off between using a faster but more expensive machine or a slower but cheaper machine. You know, which one's going to end up being cheaper? We sort of figure that out now in advance, and are more we pick a machine that will result in the lowest possible cost. And then finally, we made some improvements to our handling of parts that have patterns of holes, like the one shown on the lower right here. These patterns of holes that constitute a perforation, a feature that can be made with a multi-pin tool. And this in turn, again, enables more accurate hit counts and tool assignments for parts containing these types of features. We've also made it more flexible. Previously, we used to hard code our logic for identifying when something constituted a perforation that could be made with such a tool. Now we provide some flexibility, and you can use process setup options on the per part basis to indicate whether some rules for what should be considered a perforation. We've also sped up the costing time for parts, including those features. Now moving on to our composites cost model, we delivered the initial release of composites in our last major release, 2019 R2, but we've also delivered quite a nice set of extensions in aPriori 2020 R1 based on requests from some of our early adopters. So first, there's now a validation tab available for the composites process group, and it's really useful for determining how aPriori interprets information found in the CAD model. There's many different ways to model composites parts. There isn't really a standard, and aPriori actually had to develop our own translation layer to do this. And occasionally we may have interpreted something differently than what the designer intended. So the validation tab provides a really nice summary into the decisions that were made and also lets you easily change those, and I'll show you a slide of that next. We also now estimate the time and cost required to machine core stock to the final shape of the core geometry that's in the CAD model. In our initial release, the cores were assumed to be purchased already cut to size, but now by default we assume that those cores are both rough and finish milled from a piece of core stock that's somewhat larger than a final core geometry using a 5-axis mill. And so we've also added cutting data for aluminum honeycomb and aramid honeycomb core materials to our machining tables. And as well as for core machining tools that are called core hoggers. They're similar to flat end mills. And our machining cycle times do account for the fact that a core is not a uniform solid material, using the cell size of the core. And we've also extended our estimates for trimming times and costs for composites parts. So after the part is laid up and cured, the edges need to be trimmed. We now, in our initial release, we assume that was done by a 5-axis mill. We also now offer an option to use a water jet cutter. The mill is still the default. And we also now more accurately determine the length of the perimeter to be trimmed in some cases for a broader set of part types. Previously, in some geometries, we could underestimate the part perimeter length. So now trimming times and cost estimates will be more accurate. And we also can now read or interpret correctly some additional metadata formats for specifying ply orientations in the CAD model. Again, there's a lot of variety in how composite parts are modeled and how their metadata is encapsulated in the CAD model. Believe it or not, there's a lot of different ways to say plus or minus 45 degrees, for example. And now we recognize more of them. Previously, we didn't recognize the values depending on how they were formatted in some cases. And when that happened, we would default the ply orientation to 0 degrees instead of the intended value. That actually impacts both material utilization and layup time estimates in some cases. So reading the correct value helps, again, ensure a more accurate cost for material and the layup process. There's quite a lot of other miscellaneous detailed fixes to this cost model in 2020 R1. So I do encourage you to consult our release notes for a full description. They're all documented there. And then moving right on, I mentioned the Composites Validation Tab. Here's a picture of it, and you can see it sort of summarizes information found in the CAD model and how we processed it. In particular, this laminate summary pane summarizes things like how many plies did we find in the model, how many of them are missing sequence information, similar for cores. how many distinct material orientations did we find, all that type of information. And then if you click that review button, we'll bring up a more detailed dialog that lets you see on a ply-by-ply basis what's the information for that. And if any information is missing or not the design intent, you can easily correct it there right in this dialog. You can multiple select different plies and apply the same information, like same material, at one time. And this is a lot easier than previously, where you had to kind of go one by one through the GCDs and the GCD panel to make those types of corrections. In this release, we've also provided 2 new surface treatment process cost models, and we've extended some existing secondary processes. So first, we have a new process called Conveyor Abrasive Finishing. It is a process in which parts are placed on a conveyor belt, and then they pass through a series of abrasive belts or brushes in order to achieve a desired surface finish, or to perform like edge deburring, or slag removal or oxide skin removal. The specific configuration of the belts and brushes used depends on the functions being performed. We'd actually configured this process for a couple customers, but it was called a time saver process. That's really just a brand name. And so Conveyor Abrasive Finishing is our generalized name for this process. And then we've also included a new electroplating process, zinc nickel plating, in the surface treatment process group. Zinc nickel plating is commonly used in the aerospace industry because it provides superior corrosion protection, even more so than just zinc plating or nickel plating alone, which we already had in our baselines. It's also more environmentally friendly. And this release also provides a fast and easy way for users to estimate the cost of a large number of spot welds without having to actually define those GCDs in the aPriori weld tool or in Creo Weld if you're using that tool. So a new process setup options just lets you enter the number of spot welds for which you want to estimate the cost. This process setup option is available for both our robotic spot welding and our manual spot welding processes. And also, just a little nicety, we've added a process setup option to specify the number of paint coats for our long existing paint process. I will note that we also had a newer manual paint process that was introduced in 2019 R2 that already included a process setup option for the number of coats. And now, moving on to some of our electronics cost models. We released an updated version of our PCBA cost model in June, and also updates to the corresponding electronics data collection interface. And we'll also be releasing a second set of updates in October. So this slide summarizes sort of the combined enhancements. Our main goal was to allow users to cost a much higher percentage of a PCBA BOM with a lot less manual effort or intervention and a much more pleasant workflow. And the way we accomplish this is that we've improved the way we query the Silicon Experts electronics component library to find items listed in the BOM. And then we've also enhanced the PCBA cost model to supplement any gaps in that data collected from the electronics data collection interface. You can set up default values stored in the VPE, and that's what this new table, the component classification defaults table, does. And then finally, we flag any data gaps. We flag where any data gaps were detected and defaulted. So maybe the BOM was missing some information, maybe the components library was missing some, but then the user can easily review these and further modify them as needed. So first, now when you submit a BOM to Silicon Experts, we will return items with partial matches as well as complete matches. Previously, if there were any missing data fields, then the component wasn't even returned in the BOM export from the component data library. But for example, if it matched the part number, but not the part, the manufacturer name, we wouldn't have returned it. Now we'll return it, but just flag that it needs review. And then if some necessary costing inputs are missing, we will supply defaults based on values in our VPE table here. And what this done is it has increased the average usable hit rate by a very large amount. It's now up to about 99%. We evaluated a bunch of our different customer BOMs to come up with that figure, but compared to the results before June, in which we were getting only about a 59% hit rate. That's a fantastic improvement. I will note that about what we found is that about 84% of those matches were just correct and needed no further review. And then in some cases, we returned multiple matches because of our partial match capability, and those required the user to just look at them and pick what they thought was the correct match. And then we've also just made improvements to the workflow. It's easier to set up and verify your account with the Silicon Experts component library, so that's better for your admin. And we've just made the screens easier to work with and click to select between alternatives. And probably one of the most important enhancements we made, it was something pretty much all of our customers requested, which was that previously the error messages were not very helpful and there were way too many of them. If one of them popped up, it would pause costing of the assembly until you clicked OK, and then another one might pop up. Now the error messages, first of all, are much more informative. Before, they might just say, could not find a feasible routing. Now we include extra information that really pinpoints the component that is causing the issue. But even more importantly, you also can choose to suppress all the error messages so they don't display or interrupt the actual costing process, and just review anything that needs review once costing completes. And then finally, for the October release, we've added support for some additional process and tooling costs. We'll have a standoff insert process and a conformal coat process, as well as we're now accounting for fixturing costs for the in-circuit test process, which we already included. You will need to upgrade your deployment to leverage these improvements, but it is pretty straightforward to do that, and we've documented the steps in our release notes and other product documentation. Quickly, I want to just mention some things that we've done to accelerate the time to value and speed up how long it takes to get your data updated and using it. We are excited to introduce a new architecture that makes it easier for VPE managers at our customers to keep any configured machine data in their VPEs up to date as economic conditions change over time across their global supply base. Previously, all the machine data had to be stored or replicated in each regional VPE, even though only a few fields actually varied from region to region. So things like machine power or machine size didn't vary, just the economic fields needed to vary from region to region. But if you had any customer configured processes in your VPEs, maybe you added a configured process, all the machines for those would need to be duplicated entries across the regional VPEs. And that was time consuming and tedious. And the more regions you use, the more effort is involved in sort of creating and maintaining those economic data for those machines over time. And that's work that either your VPE manager has to do or that you pay expert services to do. So we've improved our architecture, leveraging the concept of overlay VPEs to significantly reduce the need to do that work. Now you can consolidate all your machines into a single machine VPE in which all the non-economic fields are specified only once, so there's no replication of data. And then additionally, you can associate any regionally dependent machine fields with the aPriori regional data libraries so that they're sort of tied to them, and that the regionalized overhead rates for your configured machines will be computed using regionalized data and the specific machine parameters and regional VPE properties. And so the benefit of that is those machine data fields will update automatically when you apply a new version of the aPriori data library releases. And it eliminates the need to duplicate the data across the regional VPEs, and it eliminates the need to do any additional periodic economic updates for your configured machines beyond just applying a quarterly aPriori RDL update. As with almost every release, we support most recently released versions of several CAD systems. And in this release, we've added support for Creo 7, the latest versions of the NX continuous release series, and CATIA V56 R2020, also known as CATIA R30. And then we have cost and aPriori plugins available for those versions. and then also Inventor 2020 and SolidWorks. And just a quick reminder that if you are planning to upgrade to a new version of your CAD system, please let your aPriori account team know as soon as possible. That way we can ensure that we have also made sure that that CAD system is supported in our product and you won't experience any outages in your ability to use aPriori. And with that, I'm going to turn it back over to Karsten.
Great, thank you, Karen. We've covered a lot of great content, and this is more sort of, I think, reiterating the release schedule that we typically try to adhere to and should be familiar to many of you. We try to sort of focus on 2 to 3 major releases a year and then some service packs in between. So I think what we just talked about was our sort of second major release for 2020. We had 19, maybe third, we had 19.3 earlier this year and 19.2 at the beginning. And then service pack, there's one coming up pretty soon. I'll talk about that in a second, the service pack 1 for 20.1. There's 4 regional data library updates as well that are spread throughout the year and then sort of available in conjunction with everything else. So specifically for upcoming releases, there's a few key dates to highlight. So 2020 R1 for our on-premise customers is available now. For the cloud upgrades, there's a process to sort of preparing that in the cloud and deploying it and making it available for all the upgrades that we're planning. So that is scheduled for next week, actually. And then we'll, I think a lot of you that are in the cloud have probably already heard from your CSMs about upgrade plans. There is a service pack that's coming out in October, November, and I'll touch on the details of that in the next slide. And then right now we're looking at our next major release in March, April 2021. For the service pack specifically, and Karen covered a tremendous amount of great new exciting content in 20.1, and there's going to be even more great new exciting content in the service pack, and actually a couple of brand new elements too, or processes that we'll support. So multi-shot molding will be included with assembly molding. So that's, I think, exciting to have that capability built in. And then on the sheet metal side, there's, I mean, relatively recently, there's a new line or more advanced line of fiber optic lasers that are more powerful, faster, more stable. So a lot of customers have those lasers. We're sort of moving to supporting those machines and calculating the cost for using those in the routing. So depending on, I think, your application and that's the part, it might choose that as the routing going forward. So I think for each of those topics, there'll be more detailed content available about exactly what machines and steps and scope of those two are. So keep a lookout for that. There's more DTC enhancements and coming on sheet metal and machining. Again, we'll share more detail about what those are as we get close to a service pack. As we do in pretty much every service pack 1, that's where the language translations come. For, at the moment, just for aPriori Professional. So that applies both on-prem and cloud. We are looking at language translations for the web application CI design, probably starting with our major release next year in March, April. And then one last point, doesn't change the workflow that much, but we're making some ease of use. There's some enhancements around the plugins that are coming in the service pack, where we are going to use a Chrome-based browser that we launch instead of IE11, as the IE11 Internet Explorer is nearing its end of life and support from Microsoft. So we're focused on making sure that we have the latest technology and are able to sort of also deliver the latest kinds of apps in that experience. A quick snapshot of Service Pack 1. A lot more stuff there to come in terms of details, but gives you, I think, a taste for what we're working on. And then lastly, a few links. So there's a detailed webinar where I talked about Cost Insight Generate at the beginning. There's a great webinar that a product management team did back in, I know exactly when it was a few months back. There's some videos about investment casting and matrix costing that Karen shared, so that's great additional content. Of course, as we release, you'll find release notes and documentation for all the shipping releases, 20.1 and the service packs, extensive knowledge base. You can always get to that on our help center. And then for details around cloud and upgrades and migration, any questions around that, please contact your CSM, your account team, and they'll then bring in the right PM or expert to help answer any of those questions. And of course, any questions in general about what you saw today, I think we have some time now for that. And of course, happy to follow up to anything that we don't get to. So with that, thank you. And we'll move on to the question slide and open it up.
Excellent. Thank you, Karsten. So we are running a little bit over, but there's a couple good questions in here. So I think we'll probably take two that look really interesting for the general population, and then we will answer any other questions that we can't hit by email. So the first one that came in says, you updated machining data for milling and drilling, but what about updated settings for turning operations? So I think I'll direct that to Karen.
Thank you, Rick. Great question. We are actually working on a compatible set of updates for the turning operations as well. We're actually just about finished with them, and we're just making a decision right now about whether they're going to be in our service pack or in the next major release. It's pretty likely they will be in the service pack, but in the event they aren't, we could also work with your account team to just get you the data to incorporate in your VPE if you are anxiously awaiting it.
Perfect. Thank you, Karen. So one more here that is related to some of the new functionality that's coming out with 20R1. Somebody's asking, will matrix costing be available in Cost Insight Design? So I'm going to send that one out to Karsten.
Yep, good question. So exciting new feature initially for 20R1. It's just in aPriori Professional. You can access that certainly with your existing on-premise solution or within AP Pro in the cloud. That is sort of one of the top enhancements on our list for the web applications, either within CI Design, or we're actually also working on we're calling Cost Insight Source application, and matrix costing will be a key capability there. So expect that. We're hoping to have that in the 21R1 release in the spring next year.
All right, fantastic. Thank you, Karsten. So that's all for now, folks. I hope you found this to be useful in really kind of keeping up with all the new functionality that aPriori delivers. Again, thanks to our product management and development teams, and you folks have a great day. We will talk to you soon.